All right, let's look at the practice problems. So first we have to identify our inside function and our outside. Our inside function here is the 4 ln x plus 1. So derivative outside, derivative tangent is secant squared. Derivative natural log x is 1 over x, so we've got 4 over x. Derivative of 1 is 0. So our derivative of this composition function is equal to the derivative of the outside with the inside remaining the same, times the derivative of the inside. In this case, we have secant squared g of x times 4 over x. So we've got 4 secant squared, and our inside was 4 ln x plus 1 divided by x. For number 2, we have to rewrite. So that fifth root is the same as saying 1/5 exponent, and then when we bring it up top, it's going to be the negative 1/5 power. So we've got our inside function here being the 5x cubed minus 6x. So we've got 20 g of x to the negative 1/5. The derivative of which is negative 1/5 times 20 g of x to the negative 1/5 minus 1, or negative 4 g of x to the negative 6/5, or negative 4 over the 5th root of g of x to the 6th. So that's the derivative of our outside with the inside remaining the same. Now we need the derivative of our inside being that 5x cubed minus 6x. The derivative of that one's pretty fast. You bring down your exponent, make it one smaller. And anything that's just x, the x goes away, it's just the coefficient. And now we're ready to use our chain rule, which says the derivative of a composite function is equal to derivative of the outside with the inside remaining the same, times the derivative of the outside. So we've got, in this case, negative 4 over square root, fifth root, g of x to the 6th. So I'm going to replace that with g of x. So I've got 5x cubed minus 6x to the 6th. And that's times 15x squared minus 6. So we distribute that negative 4, you're going to get negative 60x squared minus plus 24 divided by the 5th root of 5x cubed minus 6x to the 6th. our outside function here, oopsie, natural log, our inside function, 5 cosecant x, derivative of the outside with the inside remaining the same, derivative of the outside, oopsie, it's negative 5 cosecant x, cotangent x, derivative of the composition, is equal to the product of these two. So we've got 1 over g of x times negative 5 cosecant x cotangent x, or negative 5 cosecant x cotangent x over g of x, which is 5 cosecant x. And we've got some common stuff here, so the 5's cancel, the cosecant x's cancel. You've got negative cotangent x. So that one actually works out to be kind of funny. Oh wait, I feel like I made a mistake. That's because I did. Getting sloppy, Donahue. No, I didn't. You're all good. All good in the hood. So for this guy, our outside function is sine. Our inside function is 5 cosine x plus x. Derivative of the outside with the inside remaining the same is cosine g of x. Derivative of the inside negative 5 sine x plus 1. Derivative of the overall composition of functions and 2 more. These ones are hopefully going to be a little bit faster. So rewrite f of g of x, our outside function being that 1/9 power, our inside function being a 3x cubed minus 1. Derivative of the inside, 3 times 3, x to the 3 minus 1, or 9x squared. Derivative of the outside with the inside remaining the same. Bring down that exponent, make it 1 smaller. So we got 1/9 g of x to the 1/9 minus 1, which is negative 10/9. down here, that's going to be 1 over 9 ninth root of g of x to the 10th. Our derivative of the overall composite function is equal to the derivative of the inside times the derivative of the outside with the inside remaining the same. So we got 9x squared for the derivative of the inside times this other guy, this hot mess here. Nines cancel. We've got x squared over 9th root of g of x to the 10th. G of x is 3x cubed minus 1. And that's our final answer. We've got one problem left. Where is it? Oh, there it is. It's hiding. So I'm just going to write the problem again. Making the square root a fractional exponent. Okay, so we've got f of g of x, where our inside function is that exponent 3 times x to the 1/2. Derivative of e to the x is e to the x. That guy stays the same. Derivative of the inside, bring down your exponent, make the exponent 1 smaller. Rewrite as a radical. There we go. Overall derivative of the composite function. It's the derivative of the outside with the inside remaining the same, times the derivative of the inside, which is going to be e to the g of x, which was that 3x to the 3 square root x, times 3 over 2 square root x. So we got 3e to the 3 square root x divided by 2 square root x. And that's all, folks.